Good day, everyone. Welcome to another episode of Learn Math with Doc Gilma. Are you ready, guys, for the next lesson? So if you're ready, just sit back, relax, and listen carefully to the topic to be discussed for today. Alright, let's begin. The topic I will be discussing for today's lesson is all about finding the coordinates of P of xy on a unit circle. Consider the unit circle here, class, from 0 degrees to 360 degrees. We have here the coordinates for both cosine and sine functions, or the x and y coordinates. So from 30 degrees, 45, 60, 120, 135, 150, 210, 225, 240, 300, 315, 330. These are all spatial angles, wherein the reference angle is only 30 degrees, 45 degrees, and 60 degrees. For 0 degrees, 90, 180, 270, and 360, these angles here are all quadrantal angles, wherein if we are to get the coordinates in a unit circle, from 0 degrees we have 1 and 0, wherein cosine of 0 is 1, sine of 0 is 0, or the P of xy is simply 1 and 0. For 90 degrees, P of xy is 0 and 1. For 180 degrees, P of xy is negative 1 and 0. For 270 degrees, P of xy is 0 and negative 1. And 360 degrees, P of xy is 1 and 0. So as you can see, from 0 to 360 degrees. In a unit circle, we have the corresponding x and y coordinates, or P of xy. Consider sine and cosine function. For the point xy on a circle of radius r at an angle of theta, we can define two important functions as the ratios of the sides of the corresponding triangle. So as you can see here, class, from the reference angle, we actually have here the radius r and the distance of the x-axis through the point P is simply y, and the distance from the origin and the line perpendicular on point P is simply x. So from here, we can actually define sine and cosine function. For sine theta, we simply have sine theta is equal to y over r, and cosine theta is simply equal to x over r. So take note of that. Consider an illustrative example number 1. The point negative 3, negative 4 is on the circle of radius 5 at some angle theta. Find cosine theta and sine theta. In this particular example, class, the radius is already given, which is equal to 5. So using the definition for cosine theta and sine theta, we simply have sine theta, which is equal to y over r. Just substitute the given values for y and r. So this is simply equal to negative 4 over 5. For cosine theta, which is defined to be equal to x over r, is simply equal to negative 3 over 5. Therefore, P of xy is just equal to negative 3/5 and negative 4/5. Take note, the x coordinate is simply cosine theta and y coordinate is simply sine theta. So P of xy is just equal to negative 3/5 and negative 4/5. Consider illustrative example number 2. Given a unit circle, find cosine 270 degrees and sine 270 degrees. Consider the given figure here, class. So we have the x and y axis and a unit circle. So from the initial side to the terminal side, we actually have theta, which is equal to 270 degrees. From this point to this point of xy, or actually the point of origin to point of xy, we actually have the radius r, which is simply equal to 1 since we have here a unit circle. So using the given definition, class, for us to determine the coordinates of P of xy, sine theta, which is just equal to y over r. Take note that y is negative 1 and the radius is equal to 1. So just substitute the given value here. So negative 1 over 1 is simply equal to negative 1. For cosine theta, which is defined to be equal to x over r, notice that the point is simply at the point of origin. So x is 0 and r is 1. So we have here 0 over 1, which is just equal to 0. So therefore, the coordinates of P of xy is simply equal to 0 and negative 1 for theta equals 270 degrees. Consider illustrative example number 3. Given a unit circle, find cosine 360 degrees and sine 360 degrees. Consider again the graph here. So we have the x and y axis and the unit circle. So from here, from the initial side to terminal side, so we actually have theta is equal to 360 degrees. And from the point of origin to the point of xy, simply have the radius r. So as you can see here. So using the given definition, class, for sine theta, which is equal to y over r, notice that y is simply 0 and the radius is equal to 1. Substituting the given values, so we have 0 over 1. So we have here sine theta is just equal to 0. For cosine theta, which is defined to be equal to x over r, so we have here 1 for the x coordinate and the radius is simply 1. So substitute the given value x, which is equal to 1 over 1, in the radius is 1. So cosine theta is just equal to 1. So therefore, the coordinates of P of xy for angle of 360 degrees is simply 1 and 0. Consider illustrative example number 4. Given a unit circle, find cosine 120 degrees and sine 120 degrees. From here, we have the x and y axis, okay, and given angle theta, which is 120 degrees, a unit circle. Here, from the point of origin, okay, the initial side in the rotation is counterclockwise direction, P of xy, which is 120 degrees angle. Okay, so from here we can simply determine first the reference angle. Take note, 120 degrees is in the second quadrant. So therefore, the reference angle is simply the difference of 120 degrees and 180 degrees. So which is just equal to 60 degrees. So take note, class, that the coordinates for P of xy of 60 degrees is 1/2 and 3/2. So since 120 degrees is in the second quadrant, so therefore, the coordinates of P of xy of 120 degrees is -1/2 and square root of 3/2. Consider illustrative example number 5. Given a unit circle, find cosine 5 pi over 4 and sine 5 pi over 4. Again, let's draw the unit circle here. So we have x and y coordinates and the unit circle. So from the initial side to terminal side, we actually have here theta, which is 5 pi over 4. The point of origin to this point, we simply have the point of xy. Now using the definition, okay, for our reference angle, notice, class, that theta is in the third quadrant. So theta reference of an angle in third quadrant is simply theta minus 180 degrees, or simply 5 pi over 4 minus pi, which is just equal to pi over 4. Take note, class, that the coordinates P of xy of pi over 4 is square root of 2 over 2 and square root of 2 over 2. Since the given theta is in the third quadrant, so both values for cosine and sine theta are negative. So we have P of xy of 5 pi over 4 is negative square root of 2 over 2, negative square root of 2 over 2, since 5 pi over 4 is in the third quadrant. Okay, class, that's all for today. I hope you have learned something for today's lesson. Next meeting, I will be discussing more about basic trigonometry. Keep safe, everyone, and may God bless us all.